Good morning, everyone. Thanks for coming. Hope you had a good Unreal Fest so far. This is Audio Workflows and Tips for Indie Projects. I'm Nando Cordeiro, technical audio designer and audio programmer. My most recent shipped game is the indie multiplayer survival horror game Dirge, which I'm showing today. And I'm currently working as a programmer on the upcoming Bionicle Masks of Power game. I'm also currently finishing up my last year of college, so I've been busy looking for internships and jobs as well. So the game, Dirge, it is released in February of this year out of early access. It's free to play on Steam, so definitely check it out after Unreal Fest. This talk will focus on the audio work I did on Dirge while interning at Nando Games. It's an indie multiplayer survival horror game that was fully released in February, as I said. The rest of the team and I also appeared on the Inside Unreal livestream series, where we went behind the scenes on how various parts of the game were developed. So watch the recording for that if you're curious for more. It's a thumbnail on Unreal's YouTube channel. Although it's an indie game with a 4-person team behind it, Dirge has some awesome AA ambition. I designed all of the sound effects on Dirge myself and also built the audio systems myself. Everything in this talk about Dirge is geared towards indie devs making games of all scales, even smaller, simpler ones. So today I'll be focusing on audio and how Unreal's native audio systems can benefit indies. The main points are, UE's native audio features, many new things in Unreal Engine 5, and more that keep being added for each release version, and then audio in the indie pipeline, and how I overhaul the audio, plus the benefits of doing so. First, some gameplay to get the idea. So yeah, it was just some single-player action gameplay featuring the gun sounds, which I'll go more into detail. So first point, UE native audio features. When it comes to audio for an indie game, is your main issue the quality of sounds, lack of sounds, poor system design / implementation of the sounds, or all of the above? Well, UE Audio has many tools to remedy this. First and foremost, MetaSounds really being the big one. MetaSounds are now production ready in UE 5.4 and currently using all of Epic's titles. So just to clear up any possible confusion, there exists MetaSound source and MetaSound patch assets. When I say MetaSound by itself, I'm referring to MetaSound source assets. These are the actual assets that play your sounds, kind of like sound cues used to be. MetaSound patch assets are most analogous to material functions in the material graph. They're really just macros you can use in your graph to help you stay organized and cut down on repeated operations. MetaSounds are a huge step up from sound cues in terms of possibilities and detail. They actually feel and behave similar to the material graph. So they shouldn't feel super foreign if you're the one working with materials on your indie team. So C. So this is a gunshot, example of a gunshot, one of many you heard in the gameplay demo. It's a good example of the graphs inside graph features of MetaSounds. Probably one of the biggest strengths. So let's just hear this. Oh, it's a little. No, if it's loud, it's good. So yeah, that's just the idea. So it's composed of like a few elements. We're not just playing like a single gunshot wave, and like even then, if I were like just randomizing a few gunshot waves, it's even more elaborate than that. So we actually play it's composed of a few like granular layers, like transient, body, and mech, and then like tail for the end of the sound. So it's a few randomized elements that come together to form the gunshot sound. You could technically do this in sound cues still, but again, this is still a much easier way to do it because I use this here, ms_one-shot bass. So this MetaSound is actually, if you double click, opens another MetaSound right here that I made before. And this is basically like a wrapper for the vanilla wave player node that I use, but I expose more things and use this everywhere instead of the wave player node instead. So that's one of the powerful things. You make MetaSounds, and then out of these input pins, various things, you can then create inputs. So these inputs right here on the left, and then outputs. So yeah, so these inputs are exactly the things that when we use an instance of our MetaSound and another MetaSound, we see them exposed right here. So you don't have to do this like setup of random pitch, for example, pitch, and then gain for every time you want to actually use it. I did it once here and I use this one MetaSound everywhere. So it's like done and easy. I have so many little things that I can access if I want to. So yeah, and I use that for each layer. Yeah. So then another cool element of this sound is this like low ammo tone. So for the guns that do have like magazines, depending on how much ammo you have left, you hear like a metal click sound. Let's just listen to it. It's that like really high pitched click. But if we go to like 6 where it's full, we like do not hear it anymore. And then it gets progressively louder each time we have lower ammo. And yeah. So yeah. And if you're wondering, this, we see this input yet again from this MetaSound. This is because we can send in variables to MetaSound from Blueprint, which is, again, probably like the best, if not one of the best features of MetaSound. You cannot do that in like sound cues in a very nice manner. So we just, from our gun actor really, that has all its ammo code and variables in it already, it's very easy to just send that value to MetaSound for the audio component on the gun. And then that dictates whether we hear it or not. So yeah. So then for this gun tail swap, same thing here. We're sending a bool variable. And this bool variable is sent from just audio gameplay volume, which I'll talk about later. And this is nice because it's bool, we can choose whether we can choose which set of sounds to play based on the conditions, indoor or outdoor, which will sound more like reverby, more spacious. So this is false. So yeah, you hear that tail if you were shooting it outside. And then added with reverb, of course, to make it even more spacious. So, oh yeah, and I forgot to mention this low ammo tone. back here if we go real quick. This is the same setup that was used on Lyra, the Lyra demo. They had this cool feature. So I actually just got the code from Lyra and modified it a bit best for Dirge. And we don't actually have a sample playing. It's using this triangle oscillator, which is just like generating sound in real time. So this is a nice thing about MetaSounds too. You have less things in memory if you can just generate little things like this on the fly. And we'll talk more about generation and like synthesis later. That's that. No. So if you go to check out the last part, the gun tail swap. Again, simple like trigger compare, which is sort of like the branch in a way. And then this is nice because it goes straight to the outdoor and indoor version to our one-shot bass, which we literally just saw before. So we have like MetaSound inside of a MetaSound inside of a MetaSound. So that's the super powerful thing about it. You just make much less things and you can use it everywhere really. So yeah. Yeah, that's the idea. So if we so about the sound generators, the triangle, square wave oscillators, there's also noise oscillators. Before this actually, simple example. Okay, yeah. So we have our noise oscillator. So about these generators, sound generators, the feature was most prominently used in Fortnite and UEFN for patchwork, which was all the music generated in real time. That's like the most practical, obvious application. But using these sort of oscillators to generate sound in real time, it has some cool, lesser known applications that are pretty convenient as well. So this is just a room tone. It's just like an ambient sort of air conditioning slash, muffle of outside noise. So you don't just have absolute silence in any part of your game, which is unrealistic. So, yeah, it's a bit. So if you like barely hear it, then it sounds good. Sounds good to me. So yeah, it's pretty simple setup. You have noise is really just like the static sound we're all familiar with. Yeah, so it's that, and then if we just like filter, remove the high sounds and low sounds, then we get that muffle tone. So then, and this this setup for like room tone slash ambient wind. This was actually used on the. This was used for like the background cityscape in the city sample demo. So if you're curious and have the disk space to download it again, like check it out, because the audio for that was actually pretty cool, and that was all like MetaSound and Soundscape in its early days, and it still sounded pretty awesome. Yeah. So, and then we can sort of expand this setup with noise to be a bit more complex. Quite a few things, different noise levels feeding into different things. And then the cool thing is instead of messing with sliders in the details panel, we can have our inputs be like these little knobs as well, or like even sliders if that's your thing. So yeah, so it's really easy as a designer to like mess with the sounds and get a feel for what you want. So let's just listen to this wind system that's totally procedural, no wind wave files at all. So, maybe you're thinking this is too complex for your applications, especially if you're a small indie team with 100 other things to worry about. Part of my point for this talk isn't to necessarily teach you, but to give you an overview of what's possible. And like many things in indie dev, you rarely need to both learn a tool from the ground up and build a system from the ground up. This win system was actually based on like a tutorial online that I edited to sound best for Dirge. So if you understand the basics and how a tool fundamentally works, you can often edit things to suit your need. So, yeah. Go back to the slides. So the last point is a bit of an important one. As of now, MetaSounds, they're procedural and don't become virtualized, like looping sound cues when the listener is outside the attenuation range. We'll talk more about attenuation later, but so they will stay in the memory as if they were just like playing the whole time. So if you need a lot of simple sounds position in the world as like ambient emitters, still using sound cues may be the solution for this. Otherwise, you have to check and stop the MetaSound manually, which is just another step. And of course, you can still use they're both native. So you can use MetaSounds for some things or sound cues for some other things. So you can have both going at the same time. If you're familiar with some audio middleware tools, then the protocol there is really just you either use an audio middleware completely for all your game's audio, disabling the native features, or you use the native features instead. So you can have both, and then change stuff as more features get added or whatnot. So yeah. So the next point is about like some cool audio plugins that came in Unreal 5, Soundscape, and audio gameplay volumes, really. So they are both in beta still, Soundscape and audio gameplay volumes, but I found them pretty stable when using them, and they're both currently used in Dirge as well. So for Soundscape, we all remember the Electric Dreams demo when that was released. Procedural generation is definitely the future, and that applies to audio as well. Soundscape not only sounds good, but it's pretty simple to set up as well, taking care of spawning sounds to create ambience. So you don't have to code this and blueprint yourself. So let's just huge wood stuff. So yeah, so what that was is like, we are actually, let me open up so it procedurally, in a very designer-friendly way, Soundscape lets you adjust the spawning logic so that it procedurally spawns the wave files around you with like spatialization and everything. So let's see. So yeah, the main component of Soundscape when you go and enable the plugin are the palettes and colors. So it's like it's an art analogy of like the palette is the whole like soundscape of your environment. So you have your outside environment. There are various things. There's like here we have wind, ambient crow sounds, like a 2D ambient bend, which just like fills in the background, and then crickets. So then each of these, they can only hold colors. So what they are, they're like a intermediate between the audio file itself. So for our outside ambience, when we spawned in, we hear, let's look at this color. So the color, again, you see there's so many like sliders of every little thing you can customize of like volume, pitch, fade in, fade out. And then when you go into the color, which holds solely a single sound asset itself, then there's even so much more you can explore. And yeah, so the colors, they take in any audio file, sound cue, sound wave, MetaSound. And it's funny because this MetaSound we have loaded into the color is actually the wind system from before. So we can we have this like complex and procedural sounding wind system, and we can even use more parameters to change how it sounds. So it's super, super fine-tuned in your approach of audio that's possible. So yeah, that's pretty cool. And yes, so they do use gameplay tags to how you spawn these in. So I set it up in the level blueprint. Yeah, and the way we were actually checking is this itself is an audio gameplay volume. I'll talk more about that in a sec, but yeah, simple stuff. Just this is an enum for where the listener is, and then there's a select based on location. So yeah, gameplay tags, subsystem. So yeah, it's really just that. And then, so yeah, that's the idea. This one is super helpful to just, even if it's nice because it's good for both proof of concepting to just get randomly spawned sounds into the game real quick, and then you can even modify it to sound really good and with fine detail. So let's talk about the gameplay volume. Yeah, gameplay volume, audio gameplay volume. It's really similar to the existing. We just audio volume. That's just another one. Yeah. Basically that, but the nice thing about audio gameplay volume is that you can add these. Wait, let me show you precisely. No. So this audio volume, the default one has reverb and then submix. So it has everything attached to it already. If you want to change the reverb, if you want to change the submix, but for audio gameplay volume, it's just you added the correct components. So reverb component is part of that, etc., etc. So it's more like a lightweight modular approach, which is just a more optimized and simpler way to think about it. So yeah, that's just this reverb. So that's our gunshot from before. So yeah, has that slight bright reverb that I put assigned here. It's here now. Yeah. And also because since things are separated into components now, if you want to change how one of the components work, or make a new component deriving from one of those components, then you're not going to have to modify engine code to do so if you want to change the behavior of, it's like decoupling the effects from the audio volume itself, which is a nice thing. So yeah. Just a quick review of attenuation assets before we move on to the next point. Unreal's attenuation assets are easy to use and very configurable. Also, UE 5.4 just added in-editor live update for attenuation, so they're even easier to test and develop with. Yeah. So yeah, let's just have ambient sound playing. Sure, wasn't enough for that. Attenuation. There we go. And then, yes, we're like right near the edge. So if we're using this one. So inner and then fall off. Just inner. This is so convenient, but it's got it exists now. So yeah, we can see in real time. Oh, restarted. Oh yeah. So then, only thing is, as right now the fall off distance does not move per like as smoothly as the inner radius does with each little change. It like snaps. So we can't just like so change it incrementally to see the change. Yeah, that's the in-editor live update. It's convenient. So yeah, concurrency. So concurrency is nice because it's a tool for optimized voice count and performance, and to prevent too many sounds playing at once that'll end up sounding bad. So it limits certain audio from playing, so you don't have to write code that checks and manages audio playback for you. This is like a very simple and often overlooked thing to, again, make your audio sound less busy and make it sound better, but also to optimize performance, just have less audio sound wave in memory. So yeah, this was useful in a multiplayer game like Dirge, where every client will be making their own sounds and hearing each other, so you don't have like multiples of sounds in memory for each, that you don't need, that's unnecessary. So level for that. No. So yeah, so both are without concurrency right now. So we're going to do a little before and after. So yeah, this is the first person demo, but I modified the gun to now make it rapid fire. Oh, and then of course we need to, I'll talk more about console commands in a sec. There are some really helpful ones. So yeah. Modified it so it is now rapid fire. Let me see. It is one of these buttons. Okay. I think you guys get the point. Let me do that real quick again. Yeah. So as you saw, like we just see a total dump of sounds being played. That is like up to 20, 25-ish. Just for our rapid fire gun. And like, it is a rapid fire gun, so you need to hear a lot of sounds in quick succession. So how do you find a balance that it's clean? So, so just for reference again, we have and with concurrency, see the sound is like nearly identical, but when you saw the number of sounds in memory, that was like 4 or 5. So you can make concurrency will help you make this like it's not even like a compromise. Like those sound basically identical. It gets the point across of that like abrupt, fast succession, rapid fire shooting. But you don't need to literally have a sound play at every shot to make it sound good. So let's explore the concurrency. So for the fire, what this means, this max count, is that we're only playing 2 instances we only have 2 instances of the sound in memory actually. So it like shoots, shoot, and then like cuts off and then shoots again. So it's like rapid fire doing this instead of like tons of audio like, just being pushed into the memory. So that, yeah. So it still gets that character across. Yeah. So for the impacts, when we shoot the gun, it plays the impact sound when we hit something. But remember, we can also like shoot the projectile into the air, and then it'll be airborne for a while, and then later hit. So you can have multiple projectiles in hitting at the same time. But again, you don't need to have sound play for each one of those things. It'll only play 3 at once. 3 at most. Yeah. And again, this goes with like the oldest, the rule for how to stop. So stopping the oldest sounds that exist. So yeah, concurrency is also nice in a way because let's see. So yeah, it kicks things out of memory that are no longer needed. So if we look, for example, like this is the default sound gun shoot in the first person template, but you notice that like half of it is actually silence. So of course, like the proper thing would be to eventually get, you can export that audio file, get the audio file into like an audio editing program, cut out the silence so we only have the important stuff. So you only have the important stuff, and then re-export it so you have shorter sounds, because even if it's silence, the sound is still in memory after, just because it's silent. It plays until the end of the sound wave to be released. So then you can because concurrency kicks things out of memory, we can set it short enough so that it kicks the sound wave out of memory once we've heard that beginning transient. So like, yeah. So that's what I did with we're only hearing 2 at most. So yeah, it's kind of like a quick fix for your audio before you go and like edit it properly. So that's nice. Yeah, quick fix instead of editing many WAV files, especially if you're like audio editing is a bit more involved thing, and if you're a small indie team or solo indie dev watching this, then it can just help you save development time and be more efficient in your development. These little fixes like this. Just a few extra notes. Those were all the main features that helped most in Dirge. But some extra notes is, so Dirge was multiplayer. So everything described here works with Unreal's replication system. Just write your multiplayer code as you normally would. Like audio and VFX, like they're not replicated by default. So so it is just like sound cues. So in terms of like behavior asset wise, and also like these are just a fraction of all the audio tools available in Unreal Engine. These were just the most useful in creating Dirge thus far from when we went to, because we upgraded to Unreal 5 and the game was released in Unreal 5.4. Yeah, or like 5.3, I believe. But like there wasn't, but between 5 and like 5.3, those were the main very useful features. And they just get better with each release, and there's more cool stuff. So that was like the bulk of the presentation. Now it's mostly just talking about audio in the indie pipeline and how I optimize audio later. So yeah. So audio in the indie pipeline. So Dirge audio requirements. It's some advice that you'll find helpful if your indie studio has a small audio team or no audio team, or if you're a solo audio developer working on a production like I was for Dirge. So these are, so Dirge's audio requirements were lots and lots of sound effects, and I mean lots. It's horror, so just having scary sounds isn't enough. We need interactive audio that will immerse the player in the horror landscape that was designing the systems. Because Dirge is like a multiplayer live service / freemium style game that we were in early access. So getting ready to exit the early access. So that was a whole other challenge in itself because of it would influence the rate at which I would add in new audio features, made me find the balance between improving existing audio and making new stuff. Yeah. So about sound effects. So yeah, Dirge has lots of sound effects, over 1,000 now that the project is released. Many of these sounds being variations of the same sound, of course, not like 1,000 unique sound effects. So yeah. First tip is just get audio in the game. Audio, it adds so much to feeling for anything tactile, anything that's moving, any animation, any VFX. It'll help you conceptualize, but then also as a project like this grows in complexity, you start to notice the things that are missing sounds much more than the things that have okay but not great sounds. That was the main takeaway I noticed as Dirge grew in complexity and needed more audio. So when it comes to replacing old sounds, perhaps you know already, but simply just dragging the WAV file with the name that already exists into the content browser will replace it. There's no need to delete beforehand and update references. It makes re-importing the sounds later extremely easy. So you'll get that little dialogue in the bottom right. Yeah. So second point is at least having something to play. A quick first pass at designing the sound effects is what I did. Sometimes my first pass was actually good enough to be in the shipped game if other things popped up that needed more attention. Yeah. So part of this is also assign. It ties in with the last point of just having audio for stuff in the game. Assign fallback sounds to your parent blueprints for anything that has parent-child relationships that have audio. So in Dirge, an example of this was the sound objects make when they are simulating physics and hit surfaces in the environment, just physics, throw something and then it hits and makes sounds. So I did a general plastic / more all-purpose sound that sort of was like a fallback that could go with mostly anything. And then for specific wooden and metal objects, I made a wooden and metal sound fallback respectively for those things. So each little object did not have its own unique sound. So there's these little compromises to make because that would take a lot of time. It would be even more assets and stuff in memory and whatnot. And then, so yeah. So the nice thing about this was that, so yeah, I could always go and override a specific sound for a specific child blueprint if I wanted to. And another benefit of assigning a fallback sound to parents is that if a designer on the team creates a new blueprint deriving from this parent, it'll at least have some audio already attached to it, so I don't have to go and do yet another thing. So it's stuff is there already, and the design team likes just having, it feels more complete to at least have some audio, again, even if it's placeholder. So last point, when authoring some more technical systems, build them first with test sounds such as beeps or looping tones to make sure it works as intended in the game. Then add the sound effects, the proper ones. This is especially helpful if you're the person both designing sounds and implementing them into the game, just so you don't have to worry about two things at once. So yeah, that was me. So larger productions, there's someone who solely sound designs and then someone who solely, programs the audio systems, makes the MetaSounds. So you have to wear quite a bit more hats in indie dev, and structuring your work accordingly and to make things simpler. It really is a must because you've got to move fairly quick and do a lot. So about the system design. So again, audio is kind of an end of pipeline thing. Of course, you have visuals and then hooking the audio up to that. So as for Dirge, with most of the core systems already being built when I was ready to go in and add sound, it became important for me to understand systems from a gameplay programmer's view in order to know how audio could be incorporated into it. So I actually came onto Dirge being a totally non-technical sound designer and having to learn the gameplay programming side of it while working on it actually helped me become a better sound designer. Like, and I'm thankful for it. Like, you know, you're reading like the game audio community. You know, you technically don't have to be like a technical sound designer. You know, there are people who just solely design sound effects, but it really helps immensely. And understanding, like, I mean, this even applies if you're a artist, really, like 2D artists, that sort of thing. Understanding the technical systems can help you, you know, contribute to large projects like this with small teams where people need to wear multiple hats. And it helps your core skills. You know, it helped me become a better sound designer when I knew what it was going to do and how it was going to behave in Engine. So I'm thankful for that experience. It was tough, but it was fun to learn. So, and yeah, the very nice thing about MetaSounds and the graphs inside graphs feature functionality that I mentioned before was that I could build a system once and use it everywhere, which was not something you could do with sound cues. So it saves you a lot of time in the long run. Best example being the one-shot bass MetaSound that I talked about close to the beginning of this talk. I literally just built that once, and then that is used everywhere. And also, like, if I wanted to update that one MetaSound one-shot bass, add a new functionality or whatnot, or like even maybe the engine change, maybe engine and MetaSound changes and they add even more cool features, then I could update that one-shot based MetaSound, and that would, like, you know, propagate to everywhere it's used. So that would be nice. So about this, like, so the game getting ready to exit early access being live service, freemium, where people are constantly playing. So because the game's out there and people are playing it while we were constantly developing it, efficient debugging was one of the most crucial steps to diagnose and solve problems quickly. There's a whole suite of console commands specifically for audio that was very helpful. Be the next slide. So I showed like two or three of these. So like definitely take a picture of these. These are like, I think these are just about every console command I had to use while working on Dirge, really. And they were just like super helpful. So yeah, definitely take a picture to save that. And then, yeah. So probably one of the biggest benefits of going with all the native audio, in my opinion, was that debugging was a breeze. Oftentimes when debugging audio you made using other middleware tools, it requires a lot of back and forth between Unreal and the middleware profiler. And sometimes the amount of console variables exposed to Unreal from the middleware may be little to none, actually. So it's very simple in Unreal. Here are some of the most helpful ones, you know, the most helpful ones for me. You know, so it's very quick and easy debugging. And they show what each one does. So yeah. I think we're good. So here's a very quick and rough screenshot from our little dev test level where I have a few of these console commands enabled. So I enabled the 3D audio visualize. That's that little like sphere wireframe thingy. So right now, like, she just shot a gun, and then on that left cross and the right green cross, that's like the left channel of the audio file and the right channel. So you could change where each side plays, and then, you know, the gun, fire, and the pre-fire both originated from the gun in her hand, and the ground impact further above on the grass, right above the grass label, you know, that played right there. And yeah, and then if you also look above that chandelier with chandeliers playing like electric buzz sound from like the light bulbs. So, and that is currently, you know, because it's sound cue, it is currently being virtualized for the past 144 seconds. So that's a nice thing about virtualization. You can actually see that. It's not just, you can see that a sound exists there, but it's just not playing because I'm out of the range to hear that little light bulb buzz sound. So yeah, these are nice to use. So how I overhaul the audio plus the benefits of doing so. So in terms of for indie development, my specific way of using these tools and what I needed. So for example, if something really didn't need to be an interactive MetaSound at all or yet, then I didn't do it. I think several very simple one-shot sounds are still sound cues in Dirge. Again, the most important thing is that the game sounds good and sounds good with the corresponding animations, player interactivity. So as long as it sounded good, then in most cases it was perfectly fine to go very simple. When I first joined Dirge, the quality of sound effects for many things simply weren't good because they were still placeholder assets that stuck around. The first thing was to design better sound effects first, and then decide if I wanted to add more detail using MetaSounds features. I remember one of the comments while we were in early access a long time ago was that right after I immediately joined, was that the guns sounded like bubble wrap popping instead of actual guns. I mean, and they really did. So the priority was then to design the better sound effects for the gun and not transition to MetaSounds just yet. Then it was only in the coming year that I then decided that I can add more to the gun MetaSound, as shown before, with the tail switch and the low ammo sound and the layers. So it's gradual detail and complexity. The priority being, it's good sound design first. And of course, when overhauling some things were best still left as sound cues, which was most notably the things that I wanted to virtualize, as shown before, the virtualized 3D sound emitter. And for benefits, of course, performance is one of the big ones. Being MetaSounds more optimized, and it sounds better because we can create more detail with less work. Main example being the soundscapes and how we can create multi-layered procedural ambiances with a very non-technical tool. Soundscape, really goes a long way in striking the balance between good sounding audio and ease of use. So maybe you want to use some of these audio features in your next game or revise your current setup. How you might ensure a smoother transition to using more MetaSound in your game. So this is a code example. So MetaSounds simply behave the same as sound cues in code, and they both derive from sound-based parent class. So if you were actually adding audio to your blueprint code, like adding audio references to your, loading stuff to your audio components and whatnot, it may be in your best interest to work with sound-based references. This is a soft object reference of a sound base, but sound base is just an object like any other thing. So it may be best to work with these sound-based references in order to not hard-coded dependency to either sound cues or MetaSounds. So I don't know if you guys, have heard about this, but yeah. So sound base, sound cue, MetaSound, sound wave, their parent class is sound base. You can use that in Blueprint and send either of those three to a sound base and it'll just read fine. So this was nice too, as multiple times on Dirge, a developer would create a sound cue just to get a sound in there, super easy, non-technical. It's like programmer art, but for sound basically. Then I would go in and replace it with a full-fledged MetaSound asset later. Because in Blueprint, we are working with sound-based references, both sound cues and MetaSounds can share the same code, so you don't have to do any modification. Yeah. And we used, soft objects for a lot of the sounds for memory optimization. So that's just a macro to do the actual thing. And then we then cast to sound base like you do in a standard soft object technique. And yeah, so lastly, start simple and remember buggy implementation using all these cool features described today will actually sound worse than purposely keeping your game's audio simple. Sometimes, especially for indie dev, you're worrying about lots of different things. It's all about finding a good balance as an indie developer, or even if you're joining an indie team. Everyone's wearing multiple hats, and we're trying to make amazing things with this engine with a small team. And it really is possible, and it's super fun to do so. So I think that's about it. Please ask questions at the mic. So, yeah.